Hello, in this video I would like to show you how we can use Decorator pattern to help us keep our code according to open-close principle. And Decorator pattern is something that we can use to extend the functionality, extend the logic of individual objects without actually changing the types of those objects, without actually changing the behavior of other objects of that type, or without actually inheriting from those concrete implementations of those objects. And here we have an example of that. So let's get started. And here I've got, as previously, two classes, animal and dog. I have base class, abstract base class animal that has purely virtual function speak, and then I have two concrete classes, two subtypes, dog and cat, which inherit from animal and implement speak method. They override speak method. And I have here, in kind of client side, a function speak, which takes an abstract base class, a reference to an abstract base class animal, and calls speak method. And here I've got a vector of animals, of pointers to abstract base class animal, and I'm adding dog and cat, and then I iterating and calling speak function. And here I'm decorating one of the objects. I'm decorating one of the animals. Namely, I'm decorating dog. So here I create an instance of dog. I have object dog, which is inheriting from animal. It implements animal, and then, unlike cat, I want to decorate. I want to add some additional logic to this dog object. So I pass it to another object of type animal decorator that I create here. And then I pass that to animals, pass that as a pointer to animals, vector of animals. And animal decorator, it inherits from abstract base class animal, and therefore we can put it in this container. So let's look at this animal decorator. Here I have animal decorator, and it implements the interface of animal. We have abstract base class animal, and here we inherit to be able to pass it and use it in all the places where we can use animal, like dog or cat, and we take a pointer we take unique pointer of animal. Basically we become the owner of some animal, doesn't matter which one. It could be cat, dog, or some other animal that we take here. We take a pointer to the base class, and we put it, we move it and store it inside animal decorator as a member, as a data member, and we implement speak. And we add something additionally, some additional logics that we want to have. And here it would be simply printing decorated. And then we call on this animal that we've just got speak. And here we will see, when we iterate over those animals, we will see decorated bark, and then we will see that cat was not decorated. We will not see decorated. So let's compile it and see that we have that our cat was not decorated. So that's how we can dynamically wrap our objects and add some additional logics that we want to have without changing those base classes. For example, here we don't change dog or cat. We don't change this. We are not touching this interface. It stays the same. It's closed for modifications. But and also this client code is also closed, speak function is closed, and these classes are closed for modification. We don't need to modify them. However, we can extend the behavior. Here we'll see something different for dog. We can extend it by creating such decorators and wrapping our objects in those decorators. And we may also, if we want to add some logic in addition to logic that we added here, something else, we may have such layers of decorators. We may have decorator in decorator, we may put decorator in decorator, and so on. So if you want to have something like that, to have logic on top of this logic, we may create other animals that will be decorated and that will inherit from animal decorator. It's also possible. So that's how decorator pattern works, at least its dynamic version, and how we can use it to achieve closure, certain closure, and make our code more conformant, more compliant with open-close principle. So that's all for this video. See you next time.